All right. Welcome to everyone out there. This is Amateur Radio Roundtable, a show about shortwave, ham radio, amateur radio, electronics, and all things in between. Want to welcome you, and glad you're with us tonight. And if you're out there listening on WBCQ, we've got a fun night for you tonight for WBCQ. We're gonna go into WBCQ station. And we're going to see the new 400,000 million ton antenna. And I may exaggerate a little bit. And we're also going to go in and look at the transmitter. Did you know the transmitter tube, the single transmitter tube costs $220,000? You better have the SWR pretty close, guys. Don't want to replace that tube. But we're going to take you guys, after you WBCQ listeners, we're going to take you there. We're going to talk about the antenna, what it does, how it does it, how it's built. We're going to take you in. You can see the transmitter. You're going to hear a lot of good information about WBCQ. And, of course, we're on WBCQ, shortwave. But we're on, our show is actually broadcast on Thursdays out of WBCQ 7490, Monticello, Maine. And there's a picture of the big rotatable antenna there and the feed line going out to it. We're on about every podcast carrier out there. A lot of you listen. We've had over 100,000 downloads of our podcast. I go to the podcast occasionally and I don't download it. I just click on listen. So I don't know how many people are actually listening to it. Again, we'd love to hear from you. If you're listening on a podcast or if you're listening on shortwave, we'd love to hear from you. Send us an email to Tom at w5kub.com. Tom at w5kub.com. Let us know where you are and just, talk to us. Tell us how you're listening to the show and where you are and signal report and all that. Now, you guys on the podcast, I know the signal report is going to be 5.9 plus 20, so you don't have to give me a signal report on the podcast here. All right, so let's see what else is going on. Okay, if you will, please, I'm begging, hit the subscribe button down there, and I'm going to help you again. We're not many people hitting the subscribe button. Only 30% of our viewers hit the subscribe button. I don't know why, but that subscribe button is right there. I'm pointing at it right now. That's the subscribe button right down there. So hit that button and please subscribe to our show. Hit the like button, and everybody hit the like button tonight. I'm gonna make a count here and see who hits it and who doesn't hit the like button. But the like button helps YouTube advertise our show to more people. Hit the notify button, and that'll let you know when we come on. We came on this afternoon with a little testing, and we had a good time this afternoon. And we had a number of people that actually were notified that we came on, and they joined in with the test, and we chatted and talked about a few things. And I've got plans to have some things come up for the show in between Tuesday nights. So we're going to have a good time on days other than Tuesday night. So hit that notify button. No like button in the embedded screen. He must be on Windows 1 or something. Mark, you must be on Windows 1 if there's such a thing, man. I mean, no subscribe button. Huh. That's interesting. Don't know.
Actually, yeah, if you use the embedded screen on your link, on your web page, there is a like button.
There is a like or subscribe?
There is not.
What?
There's not either one. It's just the embedded video.
Okay. Well, maybe that's why people aren't subscribing. Okay.
Yeah.
All right. I forget where I was now. Okay. Subscribe, hit the like button, and all that. Hey, so tonight we've got a couple things going. We've been talking about building a bias T. Bias T is that device that lets you run power over your coax cable out to a remote antenna tuner or a remote switch or something out there. We for the show, we hurriedly grabbed a bunch of parts out of the junk box, and we built a bias T. It looks pretty good. It's a little bit kind of, a little kind of amateurish,
Amateurish.
amateurist, whatever. Glenn, you say it.
Amateurish.
Amateurish. I don't think that's a word. We need to
Don't-
check. Well,
don't make me go
check with Brett. He usually is 100 on all this stuff.
Yeah, grab that thesaurus, Brett.
Brett, is it amateurish or amateurish? What is it?
Amateurish is a word
Amateurish.
I've heard it used before.
Okay. All right. Well, back to our thing. It's a little amateurish. I'm saying it wrong. I said no. But we're going to talk about it. We're going to show it to you. We did some testing on the spectrum analyzer. We're going to show you how these things work. And I've got some questions about it. I want to make one change to it. I'm not real happy with one part in there. Okay, so we're going to talk about that. We're going to go take this tour to WBCQ. We're going to see the transmitter. We're going to see the buildup of the antenna and get a lot of information about that. And let's see, man, we got a bunch of Hamfests coming up. I've got scheduled to go to 3 Hamfests here in the next 2 months. Let's go around the room here and let me see. Please pardon the video pictures, but this is the best we could do in a short amount of time. And why isn't my logo on there? Where's my logo? There's the logo.
See, my contract calls for me to have the biggest window. So
yeah, well, while you're talking, I'm going to fix that for sure. So tell us, Glenn, what have you been doing, man? What?
Well, I actually have been fixing my antennas. I had a friend come out and climb the tower the other week and align my 6-meter and HF beams, so they're back on track. And I rebuilt the cobweb last week.
Oh, yeah.
Cobwebs put together. I've got a touch of tuning left on the 40-meter element because I've got the expanded cobweb. And that's it. The cobweb's back on the air, which means I'm pretty much back on the air, all radio, all antenna wise.
Well, that's good. I'm glad you got it fixed. You needed to do that because it's been broken for a long, long time, man.
Yeah, it's been busted since before the winter.
Yeah. All right.
So it's pretty strong, all back up. Looks good.
How about you, Brett? What you got going, man? You were going to go to the city council meeting tonight. No audio. I'm lip reading.
Okay, now we got audio.
Yeah.
There's
no audio. I'm lip reading again.
okay. There's a staff member of the city giving a long-winded talk, so I'm able to come over here. I'm not going to really miss anything. But what I've been working on, I was working on a microwave antenna today, and I can grab it, show it off.
Okay, I'll see it.
It looks like this.
Wait a minute. Where'd you go, man? Invisible cloak here.
Looks like just a big flat panel.
Is that like a patch antenna?
Yeah, there's a patch antenna inside the box here. There is a patch antenna, which is a printed circuit board.
Yeah.
It has patches that has patches of metal on it, and this big thing, you can see how much bigger it is. You can get the scale from the size of my head. Is a 2.4 gigahertz antenna, and so what this does is long distance Wi-Fi. It can go for miles and miles. It's got a gain of something like 18 dBi.
Yeah, that's cool.
And I'm going to be going out on the roof tomorrow and setting this up for a fellow who doesn't have internet right now. He's a long way from any place where internet is. And we're going to aim him at another antenna, at a Wi-Fi access point, and get him online. And so I'm going to attach a radio to the antenna and connect him to the internet. So that's going to be a lot of fun doing the microwave work.
So how far apart are you?
He's going to be going about between 2 and 3 miles,
yeah.
I think,
yeah.
to get to the internet. And he's a little bit off he's certainly off the paved roads. He's kind of out on the dirt road, far from town, and so we'll get him online that way. And it's a whole lot cheaper than burying fiber in the ground, and a whole lot faster. So we'll be able to do that in one morning, and he'll be online.
Well, that's good. Have you got a pretty clean line of sight shot for that?
Yeah, well, for 2.4 gigahertz, you need a pretty good line of sight.
Yeah.
And the good thing is, here we are in Wyoming. We're out on the prairie. There's not going to be any trees in the way, and so we're going to be able to do a clean shot and get him online. Now, a lot of hams do either mesh networks or other kinds of networks doing the same thing that I'm doing. This one, because he's not a ham and we're trying to connect him to the internet so he could do business over it, has to be licensed under FCC Part 15. And so this one has to obey the rules for that. So I made the antenna has, I know how much antenna gain you have, and so I can set the power of the radio so that it conforms to Part 15.
Yeah.
And it'll all be legal, and it'll connect him.
Well, that's cool. I think it's just really interesting to play with the internet and try to get internet to places that don't have it. For instance, hey, in North Carolina, we're up in the mountains in very rural area. The best we can get is a DSL, coming in on the phone line there. Not great, 5, 6, 7 megs, down, maybe less than a meg up. But, I mean, it works okay. But, boy, I'd love to try to do something over there to get something better. But I don't want to try Starlink. It's a little too expensive. And there's just not much anything else over there to do. No cell phone towers basically in that area.
Do you have a ham tower there?
A ham tower? No, I don't. No.
A radio tower.
No.
Okay. Well,
No.
if you can get to a place where you can see either above the trees, or you have a place where there isn't too much foliage in the way, you can go for miles and miles to the nearest access point, and you can probably find a wireless ISP to connect to. It helps if you're a ham and you have a tower, of course, because then you've got a good high place that probably has good visibility to mount your radio on.
Yeah. Well, I mean, we're kind of up on the edge of a mountain. That's kind of high, but you got mountains all around between you and, I mean, even if I had a tower, it probably wouldn't help a whole lot because there's mountains all around us.
Mm-hmm. Yeah. Well, the more and more people are putting up these access points to reach areas. If there are enough people there, they'll put up a tower and they'll either connect it using fiber, or they'll do a relay to it with more wireless. And so they'll put it all together. You might check and see if you can find someone in your area who's already doing wireless internet. It might surprise you. There might be someone there. It could be the access point doesn't need to be on a tower. It can be on top of someone's house.
Oh, yeah,
It can be
yeah.
on top of a water tower. It can be on top of a grain silo. Out in this area especially, a lot of people mount them on top of grain silos. And so you never know, there might be one there. You can use a radio like the one I have here and sweep and scan and try to find one, or you can call, just look again on the net and see if anyone's offering wireless internet there, because there might already be.
Yeah, there's another
Yeah.
also, and that's my phone provider, T-Mobile, also provides home internet via wireless over their 5G network. So
Yeah,
if you
there's no phone service, no phone service basically.
Oh well, you're out of luck then.
Yeah, we're up on the side of a mountain, and then we off the front porch we look down to the valley, and then there's a little river there, and across the river, her uncle and cousins live over there, and then the mountain behind their house goes almost straight up, man. It is like straight up, all trees, and it's just, I don't know how a tree grows on that thing. But anyway, I thought about one time, getting one of these cell phone repeaters, maybe some batteries and some solar panels, and going up. He owns the property all the way up to the top of the ridge. And on the other side that way, that's the direction of the larger cities where the service is. There's a college not too far on further north there, western North Carolina. But I thought about going up there, but man, I mean, it would have been a job getting up there to the top of mountain and putting that thing up there, and then when it breaks, you got to go back up there. This is a job I should hire Brett for. See, he could come over, and I could just pack up a 4-wheeler and stick him on it and say, hey, I want it right up there, man. You know, take this axe with you, cut down a few trees up there, mount this on there, and you know, relay that signal over the mountain.
Yeah, well, you know, if you want to make it real easy to do, and I've done this, you can set up what's called a passive repeater. You just hook two antennas together with a piece of coax, and you point one at the cell phone tower and the other in the other direction over whatever hill or ridge or mountain you want to get over. And yeah, you're going to lose some signal going through that, but if you've got a good directional antenna at the far ends, you lose surprisingly little. And so I've made connections for people that way. I did this once on an island up in Canada in the Strait of San Juan, where you could not see a cell phone tower directly.
Yeah.
And we were able to bounce over another island that was blocking us and get to the mainland and make a connection for some people who needed it in case of emergency.
Well, you know, a lot of tunnels use those passive antennas, I think, you know, to get a signal inside a tunnel.
Yep.
Yeah.
So the good news is that you won't have to climb to fix that unless it's like destroyed by weather.
That's true. Well, you know, I could just see putting that thing up there, and then I live 500 miles from here, right? So, and then to get a phone call from Verizon or whoever saying, hey, your radio cell phone repeater is screwing up the entire area. Turn it off. It would take me days to get back up there, man. Days, you know.
Well, that's the other nice thing about a passive one. They can't really complain.
Right.
It's not going to transmit an amplified signal that can mess up anything.
Yeah. Yeah.
So that's if I were in that kind of a situation.
Yeah, we for a while we were using the you know, they make a I don't know. It's like they may call it a mini cell, or you know, for the telephone. Verizon, AT&T, they sell these little boxes that you can hook on the internet, and it makes it look like a cell phone area. We were using it at the house for a long time, and I think they finally probably phased it out. I don't know. We used it for years over there, but now we're just on Wi-Fi calls, and that seems to work okay, I think.
Yeah, well, if you can get Wi-Fi, and we do this, you know, this is one of the things I do for a living. We connect people to the internet, and then if they have terrible cell phone service, they do what's called Wi-Fi offload on their phone, which means that they make a call, and it acts just like it's going through the cell phone network, but it's really going through their Wi-Fi.
Yeah, yeah.
And that works really well, too. So you only need to connect one thing. You only need to get Wi-Fi there, and everything
Right.
works, including your cell phone, which is kind of cool.
Yep, that's what we found out here.
You can also go the other way. There's a couple of companies. One of them is the oldest one is called Wilson, which does cell phone repeaters. And you can get just a cell phone repeater and then do internet through your cell phone. So if you connect any one of those things any way you can, using a passive repeater, using an active repeater, you can get the others.
All right.
Is that the same Wilson that did the HTs and stuff years and years back?
I don't know if they ever made HTs. It's possible.
Don't know. Maybe that's the same ones that make the basketballs. I don't know, man. I don't know. All right, hey guys, let's move on here, and I know you probably want to see the bias tee. You know, we talked about it on the show a week or so ago, and I said I'm gonna build one, and I threw one together here. I was able to scrounge enough parts up out of the junk box, or stealing a part here or there from an old junk piece of equipment, and we built one. And I'm gonna show you the bias tee. Now you can buy this bias tee out there. They're probably a little over $100 a piece or something like that. I don't know why they're so expensive. They don't have anything in them, but anyway, let's talk about the bias tees here, and show you what I got and what little measurements we did. And I've got a question about it. I'm questioning something. I'm a little afraid of something in here, and we'll talk about it in a minute. So um, let's do this. So one of the things that the bias T does, of course, is you don't have to run power out to your remote tuner or your remote antenna switch or so forth. The bias T is very simply just a device that uses your coax, and it allows you to run DC power out to the unit outside. And here's a little diagram I drew up. You can see the power, the DC in right there goes to a little choke. It goes down a coax, out the choke, and that's your power out. And it's blocked. It's blocked from going back toward the radio, or it's blocked from going into the RF side of your remote tuner or whatever you have there. So it's a pretty neat device. So let's talk a little about it. Here's one I have from MFJ. This is an MFJ bias T. This actually came with a 1500 watt remote amplifier. So the amplifier outside has the other bias T built in. It takes the bias T on both ends. So the antenna has a built-in bias T out there, and basically all that means is it's got a couple capacitors and an inductor, and that's it. So this is the one that would go, in your ham shack here. Your radio would hook to it. Your coax would then go out, all the way out to your remote antenna tuner, which has a bias T in it. And you would power this. You would put like 12 volts into this to power it.
Wow. How many? That'd be a lot of amps to get to 1500 watts. Are you sure it was only 12 volts? Maybe it was higher. Maybe it was like 40, 48 or 50.
I don't know. The voltage I'm talking about has nothing really to do with the power.
Well, less voltage, you need more current to get the same amount of power, right?
No, all the power. Let's say I put 12 volts in there at 1 amp, and or 12 volts at 300 milliamps or whatever, and that comes out the other end. 12 volts at 300 milliamps, and that just powers like the tuner. And of course, like your SGC 237 tuner, I think it's rated at 12 volts at 1 amp is what they suggest. So you just run that. Now, the 1500 watts. From your amplifier, of course, it goes in the coax connector. It goes out the other coax connector through the coax, out to the remote bias T, and then it's split out and it goes to your antenna or whatever you want to go take it to, a remote antenna tuner or whatever. So your power and your DC voltage are two separate things here.
I see. So your amplifier is at the bottom, not at the top.
Yeah. The amplifier is at the bottom. The amplifier, let's just say radio. There's a 100-watt radio there at the bottom. It goes through a blocking capacitor, and then it goes down to coax through another blocking capacitor, and it goes into your SGC 237 antenna tuner. Now, your SGC tuner out there has got to have power. So you've got to run a power line out to it, 12 volts or whatever. That requires another cable. But let's say it's 100 feet out there, and you don't want to run a cable out there and run 12 volts. So you can use a bias T, and by inserting a DC voltage on the coax through the inductor there, the voltage goes across your coax with the RF. And then at the other end, your voltage can't go through, your 12 volt DC will not go through your blocking capacitor. The RF does. So the blocking capacitor stops it. It comes back out through a choke, and there's your 12 volts right there. Do whatever you want to with it. Turn a light bulb on, or whatever you want to do with it. So that's how the bias T works. Let's talk a little about the bias T again here. So how much current will LMR 400 carry? I have no idea. Over a kilowatt, I'm sure, because I run a kilowatt on LMR 400 whenever I operate. So back to this bias T. If you look there, the little blue disc capacitors that's the blocking capacitors, and 3 of them are paralleled there. Yeah, I'm not sure. Probably that helps to get more current through. Yeah, I don't know. Some of the bias T's may only have 1 capacitor there, but in this case, there's 3 that are paralleled. And in this case, those in the MFJ are 2 .01s and a .47, all paralleled there. So I was thinking, okay, well, that capacitor and the inductance in there is going to cause some type LC circuit. So, maybe they're doing something there to make that resonant circuit outside the ham band. You don't want a big dip falling right in the middle of the ham band. And we're going to look at that on the spectrum analyzer in just a minute. So one of the things I did, I showed you guys the candy tins that, you invest a lot of money with these investment companies, and once a year they send you this little bitty box of candy right here. So I had a couple of those boxes right there. And hey, those boxes are worth at least, tens of thousands of dollars there. I mean, minimum, Anyway, so that's some nice little boxes. A lot of people use, what are they, the Androids? Glenn, is it an Android tins?
You got me.
Where they build these little cans that they build the little QRPs in.
Oh, Altoid.
Altoids. I might have, Altoids. Okay, Altoid cans. But anyway, this is just little chocolate cans right here, thin wall tin. So there you can see I rounded up some connectors and inductor and some LEDs that have been chopped out of something. So I'm getting together what we need to build the bias T. Now, okay, so I drill all my holes first in the box for bias T. Now I'll tell you something. Have you ever tried drilling a hole in a thin tin can with a regular drill bit? It grabs that thing and it bends your can all up, man. So I would just say that if you want to, drill some nice holes without messing up, your tin, use some of these stepper bits. And these stepper bits are really, really great for that. You just push it into the hole size you want, and it does a great job. And it doesn't mess up the tin. So I happen to have some of those, and they worked great there. All right, so here we go. We got our holes all drilled. I did put a power switch on my end that goes, but basically the two bias T boxes can be identical. You can use them interchangeably. Either end can swap. But on my bias T here, I wanted a power switch on my end where it goes to where it connects to the radio. That way, if I wanted to turn off the power to the remote antenna tuner, I could to reset it or something like that. So on the box here closest to the radio, I've got a little toggle switch in here, and we put an LED in here to show that the power's on. And I also put on the remote end an LED there that if you're outside, you can look and if you got power coming down the line or not. Now, here's my dilemma. I'm used to old school. You see the blue capacitors there. They're about the size of a dime. That's what I was expecting. I ordered me some 0.01s, 1,000-volt disc, and this is what I got, man. This is what I got. Now, it says right on the capacitor, it says 1,000. It says 1 kV on it. I don't know, man. That is small. To me, that's small, and I don't want to put 100 watts through that. I just don't want to do it. So I'm going to put larger size caps in here. In fact, I ordered me some 0.01s at 3,000 volt that I'm going to replace those with. But anyway, I put these in just to test it, try it out, and so forth. All right, so there it is inside the can. That's the one that's going to go down to the station. You can see the You can see the little LED there, left bottom that I cut out of something, and you can see the toggle switch and the bypass on the power input there. You can see the three little blocking capacitors there, and of course the RF choke there. Now the RF choke, most diagrams call for about a 50 microhenry choke. These were 100 microhenry chokes. I went ahead and tried one, and if it didn't work right, I could have taken some turns off very easily. I could just unsoldered one end and unwound some of the wire. But these are like ferrite wound chokes. I left the hundreds in there just for testing purposes. So you can see right here I've got the unit that goes down at the rig. I've got the unit that goes here in the shack, and I've got it connected to the spectrum analyzer. And you can see on the spectrum analyzer, let's talk a little about this. I've got the spectrum analyzer set for minus 10 dBm output. Instead of setting it 0, I could set it at 0, but it would have been up there at the very top and it didn't look good. So I just realized this, at minus 10 there, that is really 0 dB across there. Now with the tracking generator turned on, and I set the span here from 1 megahertz to, if you look at the very bottom, 1 megahertz to 150 megahertz. And that yellow line up there is the tracking generator sweeping across 1 meg to 150 megs. And look, it is right on the minus 10 line. Now, that minus 10 line is actually 0 dB, meaning there's no loss right there. No loss at all. You might see a little bit at the very, very far right end. If you look at it there, you'll see it. So let's look at the next one. So this is the next box. This is the box that would go outside. You notice it doesn't have a switch on it. Basically the very same box. I've got it hooked to the spectrum analyzer again, and we're going to be sweeping from 1 meg to 150. And from 1 to 150, again, we get the same results as we did on the first box. If you look at that minus 10 dB line up there, you can see it just follows that line pretty close. Really no attenuation except at the very end. Now, I did look at some of these bias tees that some people had built, and they put them on a spectrum scope, and they saw a pretty good dip in places that were outside the ham band. So it was just a blip there, a dip, and it came back up. So it was probably some type of LC network. It was causing that, spike or that null right here. But anyway, the capacitors I used, the 0.01s, 3.01s, and the 100 microfarad microhenry choke, looks like it has basically 0 attenuation from 1 to 150. Now let's look at both boxes connected. All right, here we got both boxes here. I got the local for the shack. I've got the remote box. I've got a piece of coax hook between them. So I've got the tracking generator going in at the end of the first one, and we're coming out the second one, and we're going back to the spectrum analyzer. So we're going through complete circuit, both ends. Let's look at the spectrum analyzer here now. All right, so if you look at this, you're starting to see a little bit of drop off up at the top end around at the 150 megahertz mark. So let's look at it a little closer. I'm going to look at it a little closer here. Here is, if you look on the yellow line to the very right, you see the little number 1. That's a marker I've got there. That marker is actually set at 146.77. And that marker tells me at 146.77, I'm seeing a minus 13.88 dBm. Now remember that line is attenuated to minus 10. So minus 10 minus the minus 13.88, there's about a 3.88 dB drop there, and that's at 146 megahertz. 146. Let's look at it back. Let's say we want to use this just on HF and 6 meters. Let's look at it here. So here it is. I put the marker, the little 1 right there. I rolled the marker back to 70 megahertz. That's well above the 6 meter band. And if you look right there, the attenuation right there where the 1 is at 70 megahertz is only a minus 10.05 dBm. Our reference is minus 10. So we're only losing 0.05 dB at the 70 megahertz. So it's pretty flat, man, from 1 to 70, 80, probably from 1 to 80, you know. All right, so let's look at it again here. So there it is again. They're basically same thing in both boxes, both ends. You can see I've got the power going in the main box, and the LEDs lit up on both of them. So we got power going across the coax that's connecting the two together. And let's see, there's another shot in them right there. Basically, there's nothing in here. There's an RF choke and your blocking capacitors. That's basically it, guys. So we painted up the little case. We painted it up, and you know, didn't scratch it up, didn't bend it up too bad, but that's kind of how it looks. So that's what a bias T is. You might look up that MFG bias T, I think, was like $130 or $40, and you really need 2 of them, 1 for each end, unless your remote device has a bias T built in. So that's my story, and I'm sticking to it on the bias T. What do you guys think? It was pretty flat. I didn't see any attenuation across, you know, up to 70, 80 megahertz. What you think?
It looks good. The only question I would have is it blocking the RF going back into your power supply and then coming out at your power supply outlet at the far end? Is it doing that well? Because you don't want RF in your power line. It could mess up a microprocessor in your tuner, and it could get into your home power if it came the other way through your power supply.
Yeah. Well, you know, I mean, we have got. Let's see, what do we got here? Let's see if we can show. We've got, that's not a good picture. Maybe I can find it. Well, we've got bypass capacitors on the power plug, which hopefully would block some RF. The bias T's been around many, many years. It's been pretty trouble-free. If you notice, there's not much to one. And they work out pretty good. So I probably would run this bias T on a little power pack, like a 12-volt power pack like that. Or I could actually take that power cord here and just hook it to the same 12-volt power supply that you know is powering the radio. I might just use a little wall wart though and power it. Good question. How many do you want?
I think that with the blocking and the coil, you know, the caps and the coil, that it'll filter out most of any of the RF.
Yeah, yeah. So it was a neat little project. It turned out pretty good. Again, I do want to change those 0.01 thousand volts to
I don't.
a little bit bigger. I mean,
You would think that 1 kV can arc bigger than that.
you know, and this MFJ right here, you see the 3 little disc capacitors?
Yeah, that's
I
what I'm-
run over a kilowatt through those to the remote. This matches the remote 1.5 kW auto tuner I have out at the antenna. So yeah, the kilowatts going through those little disc capacitors right there. Now my disc capacitor is a lot smaller. I'm gonna put some 3,000 volt ones in there, and a little bit larger.
Yeah.
I don't know.
Yeah, like I say, to me, that physical size just doesn't feel right.
Yeah, yeah, it didn't for me either. So I don't know, man. It
Yeah.
kind of bothered me a little
Well,
bit.
it's tempting just to try it and see if something smokes.
Yeah, yeah, and we'll probably do that. I'll be going to North Carolina here pretty soon. I always take my rig over there and the SGC 237 tuner. And what I usually do out in the front yard, we got a big tree out there. I usually shoot a line over a limb about 70 feet or so and drop me a vertical piece of wire and then lay me like 4 radios out on the ground. And that SGC tuner just sits out there next to the tree. The antenna's hooked directly to it. And I usually have to run me, a twisted pair or something out there to power the 12 volts, or
Yeah.
you can put a 12-volt battery out there, a little 7-amp battery or something. But with the bias T now, I can just run the power out there across the coax.
Yeah, that's a good idea. Mark P's got a question of if you're familiar with the MFJ bias T, what is the slide switch for on that box?
The slide switch just does the same thing I did with my switch. It just turns it on or off. It just sends power out or turns the power off, and that's good to reset. Sometimes these tuners just,
Yeah.
they go click, 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 and they come up on SWR. It stops at 1.8. We'll
Yeah.
say the thing ought to do better than that. You can power it off and power it back on, and then click, 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 and next thing you know, you see a 1.2.
Yeah.
Yeah.
Yeah,
All
the
right.
SGs also have the ability. They can let you freeze the memory, and they can let you intentionally erase the whole thing.
Yeah, yeah, yeah. Well, anyway, so I'm looking forward to that. We'll probably use the bias T over in North Carolina here in a few weeks.
Looks pretty cool.
So I'll be taking a rig over. I'll probably either take the new, what is it, 891 R1 over and use it. 891 or 981, whatever it is. I don't know what it is.
Nah, you got me.
It's 890. Let's see.
897?
891. 891. FT 891. Yeah. I'll either take that over or I'll take my 7300 over there. And of course, with either one of them, if you put up an antenna like I put up, you need some type tuner out there, some type matching that deal. So that's what I'll do. Also, probably going first time. I haven't done it in a long time. I'm going to be taking a VHF UHF radio over there. And as we go over there, guys, we're going to be hitting the Huntsville Hamfest first, and then drive over to Tuckasegee, North Carolina, and spend about 8 or 9 days. And then from there, I'm going to drive another 300 miles east to Shelby Hamfest. All that's happening in August, so I'm really excited about that. We'll talk more about those a little later. All right. What else is going on, guys, before we get into the WBCQ?
But did you do any of the VHF contests this weekend?
Man, I listened, and I heard a few very weak signals. I talked to one guy. He was in Somerville, and then later, either morning or maybe late night or something, the band opened a little bit more. It was noisy. I heard a few weak signals and people talking, but there was really nothing. This is not the contest I thought. The big VHF contest is in September.
Ah, okay.
This is another VHF contest. I don't know what it is, but where all my friends here in Memphis, they go over to Mount Nebo. That's in September when they go up there on top of the mountain and do that VHF contest there.
Yeah, because I had 6 meters and I was listening on 146.5 in the car and I heard nothing.
Yeah. Yep. Yeah. What do you got going here? All right, let's see. What do we got there, Brett?
Okay, well, this is a router, an internet router, and it looks like a race car because it's a fancy gamer router. And I'm working on programming the thing with special software. The software, it's historical. Why it's called this is called Fresh Tomato, and it replaces what the manufacturer originally put in the router, and it makes it work a lot better. And it's open source, so you can, even if you're really ambitious, go in there and actually modify it yourself. So I'm playing with that and trying to make a super router for my office. another computer thing I'm doing in the office. I guess this is vaguely ham radio related because ham radio helped me with it. Was that my laser printer went kaput?
Wait. I missed that. What? Your what?
My laser printer went kaput.
Oh, okay.
It stopped. It would not grab the paper. It looked like the motor burned out. I checked. It was very expensive, and so I called up the guy in the Cat in the Hat.
Yeah.
Because besides being one of your major competitors in the ham raffles, he
Yep.
also is a laser printer repairman.
Wow.
Yeah.
That's right.
And I talked with him, and we agreed that the laser was kaput. So he helped me pick out a new one, and so that
cool.
was yeah. So
Well-
I guess that isn't technically a ham radio thing, but because I met him through ham radio, I was able to get some good advice.
Yeah,
Yeah.
there you go.
All right. Well, very good. All right. So fresh tomato, huh? What do they come up with names like that?
That's been around for years. They did that first with the old Linksys WRT router series,
Really?
those 10 routers years and years ago.
Well, yeah. I mean, hey, when I was with FedEx, we had a department that ordered software and stuff for everybody, and the internet was just starting to go good, and I wanted a web page type editor, So
Yeah.
I ordered one, and my name came up in a meeting with senior management one time. They said, you'll never believe what we got. We got an order here for some software from Tom Medlin. It's called Hot Dog.
Mm-hmm.
And they said, and you never believe the company. The company name is Sausage.
Yep.
Yep.
Yeah. All right.
Probably open software.
But that was actually a pretty darn good HTML editor for the beginning of time.
Well, that was in the beginning of time. I use WordPress now. Everything's online. You don't need any software or anything. And hey, I'm not an expert, but
Yeah.
I can get around WordPress and do things. And if I want to try to figure out how to do something, Google's your friend. How
Yep.
do I do this on WordPress? Click, and
Yep.
it says, all right, do this. Click here, do this, do this, do this. I said, man, oh man, it works. You know?
Yep. I used Hot Dog for a couple of years way back when.
Yeah. All right. Well, we got Don in here. He said he made 2 contacts on 6 meters. I could have made 2, but it was so crappy. I just made that one, and
I was mobile, so I didn't hear a thing.
yeah. All right, guys. Hey, anything? What was that, Brett?
I heard a bunch of people on FT8 using that mag loop that I showed last week.
Yeah. There was some FT8 on there. I could see a little FT8 blip on there when nobody else was talking. I mean, FT8 always works, man. Yep. All right. Hey, guys, we'll be right back. Don't go away. ICOM's compact IC7100 and the IC5100 D-Star mobiles are road ready and features a dash mountable touchscreen control head with quick and straightforward one-touch operation, keeping you connected whenever you roam. The IC7100 is an HF, VHF, UHF multiband all-mode mobile with an angled control head, a large internal speaker for clear digital audio, and fully covers the HF 50, 144, 430 and 440 megahertz amateur bands. This radio provides 100 watts on HF and 50 megahertz bands, 50 watts on 144 band, and 35 watts on the 430 megahertz band. The IC5100 is a VHF UHF dual band mobile with DV dual watch, Bluetooth, and an integrated GPS receiver. For more information on ICOM radios and locate a dealer, please visit icomamerica.com/amateur. ICOM's compact. Right, we're back here. Okay. We got a few people out there on Twitter tonight, guys. We are simulcasting our show tonight on YouTube and Twitter. We've got a number of people out there actually on Twitter that are actually watching the show. If you're on Twitter and you've tuned in, we do have a chat room. We use our own IRC chat room. If you want to chat with us during the show and everybody else, you just go to w5kub.com and click on the little yellow button that says video and chat. There's a chat room right there. You can click on the chat room, and you can still watch on Twitter if you want to, but there's a chat room and you can join us there. All right. Guys, we've been on WBCQ now for, I needed to go back and look, but I think we've been on WBCQ weekly now for about 6 or 7 years, maybe a little longer.
Yeah, something like that.
It's been quite a while. Before that, we were on another shortwave station, but we decided to go to WBCQ. They've been really good to us, and WBCQ is a very famous shortwave station. Alan Weiner is the owner. I talked to him yesterday, and we've had him on a show a year or two ago. Alan had built up a pirate radio station, and FCC busted him. This was up in New York years ago, many years ago. Alan actually bought like a 130-foot ship. The engine wouldn't run in it, but he bought that ship for his pirate radio station, and he had a tugboat pull it out to the ocean off of New York. And they had, I think, I forget what it's called, Radio Free New York or something. I forget what it's called. Anyway, we had him on the show here a while back, and the FCC, we had video of the FCC going out there and busting him. The Coast Guard went out there, the police went out there, everybody went out there and busted him and took him under arrest and put him all in handcuffs and carried him out of there. It was cool. And by the way, that ship, he sold that ship later. I forget the movie. I'll try to pull up the name of the movie, but there was a movie where there was terrorists or something, I forget. Anyway, they blew the ship up, put explosives in it, and they blew it up in the movie. So I hope he got his money worth. He sold the ship, the engine didn't work, but they blew the ship up anyway. So anyway, it was the story, Alan, when he was, just a young kid, started, like many of us, experimenting with radio, building radio transmitters and stuff like that. And, of course, he got shut down. His daddy was a lawyer, by the way, and the FCC actually shut him down. They, I think they finally dismissed the case. I'll have to go back. It's been several years since we looked at it. They dismissed the case. He claims he was out in international water, and they had no jurisdiction. So I don't know. There's some law about, well, if your radio signal's interfering with signals in the U.S. or something, then yeah, you're at fault. But I kind of think what Alan's saying. He was out in international waters, and so I think they finally just dropped the charges on him.
I would think if you're in international waters, they really can't do a whole lot.
Yeah, I'll have to pull that. We got that video, guys. I don't know if you'll find it, but it's one of our
because it doesn't matter where your signal goes; they've got no physical jurisdiction to arrest you.
Yeah, yeah.
And think about it. We fought with that Russian woodpecker for years.
Yeah. Oh, yeah. That's true.
So, they couldn't stop it. So no, yeah. I they were out of line for that one.
Well, while I'm talking real quick about pirate radio station, when I was talking with Alan and learning all about the pirate radio stations, there was another one that was put on. Alan wasn't involved in it, but a friend was, a friend of his, and it was in the country of Seagate. The country of Seagate. Now, guys, if you don't believe this, you can do a Google search and look up the country of Seagate. S-C-A-G-A, I think Sealand. I'm sorry, Sealand. this is one of those platforms that during the war, England built these platforms out in the ocean, I guess, to put guns out there to protect England. And England just left them. After the war, they left them. They deserted them. And this guy went and claimed one of the platforms. It's like 200 feet by 200 feet. It's called Sealand. He actually had his own money printed. I think he had a king and a queen. I don't remember all the story, but I think some people went out there and took the place over, and he came in blazing with a helicopter and gunmen on there, and they took the Sealand back. Look it up, Sealand, and you'll see it's the world's smallest country. It's like 100 meters square or something like that. I don't know.
Was that the guy who was setting up internet servers that was supposed to be safe from governments?
I don't know. I don't think so. Back then, they didn't have internet.
Okay. Now, I remember hearing about someone who took over one of those platforms and set up internet servers, and supposedly you could do all sorts of nasty things because they weren't under any other government's jurisdiction.
That's true. Well, I think it was in dispute whether it was in a jurisdiction or not. I guess they were built far enough out in the water that maybe they weren't. I don't know. If they were in the confines of the boundaries, that you would think that the government would own it, but somehow there it is. KV5 it was in the North Sea. That's what, North Sea. Okay. He looked it up, so it's there, All right, guys, let's do this real quick. Let's go to our video and look at this. This is a cool video. It talks about building the antenna and how big it is and how much gain it's got and how it works. And it's got things I didn't know. Actually, it's got dipoles on both sides of the antenna, and it's got a curtain down the middle. And depending on, I guess, which way you want to go, you can turn the antenna and use either side. The dipoles on the back side, the dipoles on the front side. And man, you can get a very narrow beam with that sucker. This is probably the largest rotating antenna in the Americas, not just the United States, but in the Americas. 500,000 watt transmitter, effective radiated power about 20 million watts, I think is what they say. So let me get that up, and we're going to watch that, and we might stop it and comment on it here in just a minute. I don't know. Let's see. All right. This is Alan Weiner. He's the owner. Alan is the owner, and that's his wife, Angela, who is co-owner. And there we go. Okay, here we go. All right.
This is WBCQ, bringing world's last chance radio to you from Monticello, Maine, USA.
WBCQ, Monticello, Maine, USA.
With 500,000 watts out, this tube rig rocks.
Type 176 Tetrode, which is an output tube, costs $210,000.
Troubleshooting complex solutions for advanced technical problems.
The fix for that was masking tape.
A transmitter made by Continental in USA.
Continental builds great equipment.
The superstation WBCQ is Northern Maine's 20 million watt shortwave powerhouse for the world. A little over 4 years ago, World's Last Chance Ministry teamed up with Monticello shortwave radio station owners Alan and Angela Weiner to create the most powerful radio station in Maine, and perhaps New England. World's Last Chance bills itself as a non-denominational church that has become dissatisfied with the watered-down truths preached in establishment churches today. World's Last Chance Radio is developing a series of end-time messages that will be broadcast worldwide in 10 languages over shortwave radio from WBCQ.
We're a Ma and Pa organization. Here's Ma, co-owner of all of this madness. And our goal is free speech radio. And our client, World's Last Chance Ministries, which are wonderful, beautiful people. They are just the most pleasant people on earth. They are God-fearing. They love our Lord and Savior. They're wonderful, wonderful people. They came to us because WBCQ has the reputation of being the foremost free speech radio station in the world. That's why they came to us. And they said, we want to be on your transmitters. And I said, fine, we'll put you on our transmitters. And they said, well, how much power are you? So we're 50,000 watts at the classic site. And they said, well, that's not enough. We need more. I said, well, we don't have more. I said, well, build more. I said, well, fine, we could do it, but it's going to cost millions of dollars. And they said, fine. So so we got into a pretty informal arrangement where they sponsored and provided the financing for WBCQ to expand and build what we call affectionately transmitter and antenna number 6. And we built it, and all on the foundation of freedom of speech, freedom of religion, and it's been a wonderful relationship, and they've been doing, God's good work, and here we are today, and I think it's vital because, well, the cancel culture, everything that's going on now. Freedom of speech is at jeopardy, and the superstation, we feel, is a world asset because other nations are tearing down shortwave stations left and right.
Construction for the new radio station began at the Wieners' long-standing location on Britain Road on the outskirts of the small-town community of Monticello in northern Maine. The most visible sign of WBCQ is its massive antenna array, towering above the treetops. Since nobody is building large-scale rotatable antenna arrays with variable beam width patterns in the U.S., the Wieners had to look to Europe for the solution.
Well, it's the antenna itself. I guess you would say the brains in the antenna.
Yeah.
That was
so.
Germany.
Yeah. Everything was fabricated in Germany and Switzerland, and was shipped over here from Germany and parts from Switzerland. Some of the steel parts were fabricated, believe it or not, in China, and they were shipped from, I think, Hong Kong and Singapore. So the antenna is very international. It has components from companies all over the world. The electronics in it are primarily from Siemens?
Yeah, in Italy.
In Italy. And some other controllers are from other European nations. So it's really an antenna of international proportions. It's a massive computer structure. There are motor controllers. There are digital sensors that monitor certain parts of the antenna that are water cooled. There's a section of the antenna called the tubular section, which comprises about 100 feet from the base up to a superstructure that goes another 120, 130 feet up. And in that tubular section is all kinds of massive switching, and there's the antenna tuning unit, which matches the 500,000 watts from the transmitter to the various dipole antenna bays.
The antenna mast at WBCQ is 260 feet high and weighs 400,000 pounds. For an antenna of this size, it was an engineering miracle to design the tower to be fully rotatable through 360 degrees and allow for instantaneous adjustment of the radiation pattern of the RF energy from wide to very narrow, similar to an adjustable beam flashlight.
Because the antenna is actually made up of 16 dipoles, 16 dipoles that are switchable in all different kinds of configurations. It's kind of like a radio searchlight is the best way to describe the great antenna that we have here, built by Ampagon in Switzerland. It can be like a flashlight that has a controllable beam. We can do the same thing with that antenna. We can set the dipoles at various configurations to make the beam like fat this way, narrow this way, or fat this way, narrow that way. And that helps us get into just about any country on Earth, depending on where we're pointing it. All the dipoles act as the radiating element. The reflector is a huge copper screen that is mounted behind the dipoles. It's actually known as a curtain antenna because it has a curtain of wires, copper wires, thick copper wires behind the dipoles that give it directionality.
The antenna array is actually a dual band configuration with a matrix of dipoles on either side of the copper screen curtain that are designed for different portions of the shortwave bands.
If you look at the antenna, you look at photographs, you'll see that there are these big white dipoles which center around 9 megahertz, even though they're tunable from 5 to about 12 megahertz. Then there's another set of dipoles, another 16 dipoles. They're smaller. They're on the back, and they go from about 15 to 30 megahertz. So depending on the band of frequencies that we want to use, depends on whether we're using the white dipoles, the bigger ones in one side, or the smaller ones, which are painted red in the back. That's the versatility of the antenna. So the frequency range of the antenna is basically 5.8 megahertz up to 30 megahertz. We can use 2 dipoles, we can use 4 dipoles, we can use 8 dipoles, we can use all 16 of them. When we really have to put a narrow, like if we're going to the Arabic-speaking world, which is kind of on the other side, or if we're going to beam down to Australia or someplace like that, we'd probably use all 16 dipoles with a pretty narrow beam directed at a heading to get into that area. It's like an optical searchlight that we can change the beam focus whenever we want. The switching of dipoles is commanded here, via a computer, but the switching is done at the antenna in the tubular section. How many levels are there? What is it? There's like 7 levels.
7,
yeah.
And it's on
Right.
4?
Pardon? I think it's on 5 and 6.
Would those be
It's been a while.
solenoids that are closing?
They're big RF switches. They stand like yay high and wider than probably both of us. And they have these ceramic arms with these metal fingers on them. And they're run by electric motors and solenoids. So when they command to go to like a 4x4 configuration or a 2x2 or an 8x8, the switches will go and switch in, and these big arms will like switch over and hit into a pad to, because there's a lot of voltage and a lot of current at 500,000 watts. And that's how we configure the antenna. And it's all done from the control room here. And everything is controlled by the Siemens controllers.
The antenna mast at WBCQ is secured to a concrete base 40 feet by 40 feet by 12 feet deep, which is anchored to the bedrock beneath it.
Incredibly rebarred. And that sits on top of ledge here.
And then, of course,
And it will not move. Everything is grounded and strapped to and welded to the rebar cage, which is all welded together, and that forms the ground base for the antenna, mainly for lightning. But it doesn't use a ground screen per se like an AM transmitting antenna would use. It doesn't need it because it has its own reflector in the curtain reflector.
The $500,000-watt, $30+ million radio station was built from scratch, from the ground up. But Alan and Angela found at the beginning of the project that it was difficult to convince some of the vendors to take them seriously about the project.
Building a 500,000-watt shortwave transmitter with a fully rotatable antenna is no easy task. It takes a lot of planning and a lot of devotion and just a lot of dealing with all kinds of thousands and thousands of little issues. But that's really how we started. You know, you pick up the phone and you go, hey, I need a 500 kilowatt transmitter. What can you do for us? Can you give us a quote? But it's interesting, though, that in the beginning, when we did that, we weren't taken seriously. It took several months before the vendors started to really consider that we were serious. Angela was in the construction business before we got married and together, and the attention given to people that want to do stuff, you know, big stuff, was a lot better. I mean, I did find it a little, strange that there was this kind of reluctance.
The main engine of the transmitter is a large water-cooled vacuum tube designed to convert 10,000 watts of input into 500,000 watts of output RF power.
The transmitter is actually, it's simple in concept, where you basically have a master oscillator, a frequency synthesizer, that goes into an IPA stage that boosts it up to 1 kilowatt, that goes to a vacuum tube driver that boosts it up to about 8 to 10 kilowatts, and then that goes into the Thales 176, type 176 tetrode, which is an output tube. It's about that high, about that wide, costs $210,000, is water cooled, and it will take 10 kilowatts in and basically give you 500,000 watts out. But the gain of the antenna, depending on the configuration, can boost it up to 20 million watts. And we do that so people that have a small, little, cheap shortwave radio can just pull out the little antenna, tune in 9330, and hear us.
The transmitter is cooled by a combination of circulating air and a closed-loop water system. The water cooling system is based on distilled water, which pulls excess heat from the transmitter to a heat exchanger. This water is constantly monitored for its electrical resistance, so it won't create an opportunity for any stray currents inside the transmitter system.
Everything's water cooled in it. The capacitors, the vacuum capacitors, the coils, all the tubes, the tube sockets, the mounts, everything is, the majority of the big RF components are water cooled, and then the rest of it is circulating air. And we distill our own water to opt up the system, because the cooling water for the transmitter is a totally closed loop system, and there are two. There's an outer loop that feeds the outside heat exchanger that has to have glycol in it because it gets so cold up here. And then there's the inner loop that has pure distilled water. They actually have both distilled water, but the outer loop has glycol. The inner loop has nothing but pure distilled water. And we monitor its conductivity. It has to be below, has to be so many, megohms of resistance to be able to use in the transmitter, so it doesn't conduct voltage or RF as it circulates through all the, to cool all the plates or the anodes of the big power tubes. So that's to top it off. Occasionally there are leaks. I mean, the transmitter has hundreds of little fittings and lines. It is really a plumber's nightmare. I mean, running BCQ, you have to be a computer person, you have to be an engineer, you have to be a mechanic, and you have to be a plumber. You need you need all these skills to be an engineer here at the World Superstation.
As can be imagined, A transmitter of this magnitude will present its own unique set of problems and challenges for engineers to troubleshoot out.
And we had all kinds of interesting problems with it when we first were firing up. What was the first problem?
Screen ring.
The screen ring, the leak. It's all water cooled, so the transmitter sprung a leak in the power amplifier stage when we were first testing and firing up. And it dribbled down the side of the tube and shorted out something known as a screen ring, because the tube has an accelerator voltage that works at around 700-800 volts. And it shorted that out. So we had to pull the tube out and clean all that and fix all that up and put that back.
Alan is an old-school radio electronics technician with many decades of experience in station design and operation. In one instance, he had to take the transmitter's designers to task to deal with an RF problem inside the transmitter that was causing component failure to occur.
Then there was a problem with the grid input circuit, which kept burning these bias resistors up. And I kept telling Continental that the design of the grid feed was wrong. It's interesting when you deal with a big company that's basically, and they build good stuff. I mean, Continental builds great equipment. Their equipment is well designed and good. In this particular instance, Angela knows because of the frustration of all the emails that we sent them saying, no, your grid input circuitry is wrong. There's too many circulating parasitic currents there that are going to create heat and blow things up. And finally, they, without really agreeing, they changed the design. And they said, you're right, we need a choke here, we need a choke there. They redesigned it. We haven't had a problem since. It's simple in concept. The transmitter is complicated because it's controlled by Windows 10 operating system, Windows 10 operating system, which has its own issues. And everything's monitored. The transmitter is really well monitored for temperature, fluid flow, backward RF, visual, overloads. There are even little arc detectors in it, which were driving us crazy. Remember how they were driving us crazy? Because there was a crack in one of the doors, and the sunlight would hit it on a certain day and trip one of the arc sensors and dump the transmitter. So the fix for that was masking tape. So we did all kinds of little things like that. But finally, after a shakedown of about 6 months, we got it operating pretty smoothly.
The transmitter is powered by a 14,000-volt three-phase power supply. The local power company actually had to build a new three-phase infrastructure through the small town of Monticello to provide power to the new radio station. The transmitter is powered by a three-phase 14,000-volt audio-modulated power supply. The power supply is composed of multiple smaller power supply modules, which are connected to the audio feed via fiber optic cable. The power supply itself is what provides the amplitude modulation, as it is increased and decreased according to the audio frequency, which then modulates the 500,000 watt RF output tube to create the AM signal that puts the station on the air.
The power supply is an interesting situation. It's 14,000 volts, and it's all digitally controlled. Imagine a power supply with 48 800-volt little power supplies, and they're all connected by fiber optic to a computer. And the computer tells all those, and they're all wired in series. So the computer tells all those power supplies when to turn on and by how much, according to the audio modulation, the music and talk that goes into the computer. That's how the transmitter modulates the RF carrier signal in the air. Basically, it's a bunch of series power supplies controlled by a computer to go on and off at an audio rate. It's simple in concept, a bit complex in application. The superstation is kind of like on the level with, it really is like a power station, because we have, three-phase megawatts of power coming in from the local power company, and then we convert it to the final 14,000 volts to run the transmitter, and we have a huge electric bill, but it's worth it. It's a lot of fun.
The feed line that connects the transmitter output to the antenna array is a coaxial copper tube that runs from the transmitter out to the antenna array several hundred feet away from the transmitter facility. The outer portion of the feed line is a 9-inch diameter copper tube, which acts as the shield, surrounding a smaller 4-inch diameter copper tube that is the feed line's center conductor.
We have a 9-inch feed line. Imagine a copper pipe 9 inches in diameter, and then running through the center of it. How big is that center conductor? What is it? It's about 4 inches. Yeah,
I was going to say.
because it's 50 ohms. It's about a 4-inch center conductor,
It's been a while.
and it's known as a coaxial line. It's the same kind of coax that you would use, like on a CB set, to connect your antenna to your CB set, except it's 9 inches, and it has a rating of about, I think it can do about 1.5 million watts is what it can carry. The 9-inch outer copper pipe is the shield, and the 4-inch inner copper pipe is the actual center conductor that conducts the RF energy.
Center copper solid or just a tube?
It's a tube.
Okay.
Yeah.
So what's the dielectric? Is it just air?
The dielectric is air, meaning the insulating medium is air. The center conductor is held in the transmission line by these huge nylon rings, and then we pump dry air in it, desiccated air, no moisture, and that's the dielectric. That's what insulates it from one area to another.
The 50 ohm balanced line tubing is then connected to an antenna tuning unit inside the antenna mast. It feeds balanced line systems that then go through a series of RF switches and a rotating mechanism to allow the mast to rotate 360 degrees while maintaining an electrical connection to the dipoles.
The 9-inch line goes into the base of the antenna. It hits an elbow, so it, right angle elbow, and it goes straight up. The first place it goes is into an RF switch that enables us to do maintenance on the antenna. So we can switch from the transmission line to like test equipment at the antenna for tuning purposes. Then from the RF switch, it goes to a rotary joint. And the rotary joint is interesting because what it is, it's a piece of 9-inch line that's cut in, 2 areas? And it has all these metallic fingers. And it rotates because the antenna can rotate. And so it goes to this rotating section. And then above that, it goes to something called the ATU, the antenna tuning unit. And in the antenna tuning unit is a series of coils and vacuum capacitors that are all tuned by electric motors, and they have sensor, Selson sensor sensors on them that tell the computer what position the vacuum capacitors and the coils are, because for every frequency and for every configuration of the antenna tuning unit is important to match the 50 ohms of the transmission line to the roughly 200, 300 ohm balanced lines that come out of the ATU and feed all the dipole arrays. So it's quite a mechanical marvel. I had engineers out there with test sets that feed signals into the antenna at very low power, like a watt, and they measure the reflected power back, and they can tune the antenna tuning unit and preset it for all the operating frequencies we may be using now and in the future. Currently now, the station is set for 9330 kilohertz. And we don't really have any plans to change frequency. We're kind of sticking with one frequency because the signal is heard so well around the world we're trying to establish 9330 as the frequency for this WBCQ World's Last Chance station.
The studio for the superstation WBCQ features state-of-the-art digital sound cards, a digital mixing console, and PC-powered antenna rotating software. As a bit of nostalgia, there is an old Collins radio in the rack that is used to monitor the on-air signal of the station. Shortwave radio is a 100-plus-year-old technology which goes back to the early years of the 20th century, long before internet and cell phones have spoiled society with the instant gratification of news, data, and information at their fingertips in a split second.
To me, shortwave radio is vital. I mean, the internet is fragile, and we have listeners. Like just yesterday, we got an email from a listener way out in the willy wags. Doesn't have internet, doesn't have a computer, doesn't want one. And he had an old vacuum tube shortwave radio in his basement. This is just yesterday. And he cracked it open and tuned it in, stuck a 1 meter piece of wire out the back of it, and tuned in one of our stations with all the crazy, wild programming that we have. And sent,
wasn't it our
you know,
show?
and you know, sent us a text on his phone and said, "Look, I just tuned you in and we love it. Thank you for being there." And shortwave radio is something I think will always be with us. You know, we get into the basements and attics of North Korea and the areas of the Arabic-speaking world where people, don't have broadband access, but they have a $5 or $10 shortwave radio. That's why we broadcast a 500,000 watts, but the gain of the antenna, depending on the configuration, can boost it up to 20 million watts. And we do that so people that have a small, little, cheap shortwave radio can just pull out the little antenna, tune in 9330, and hear us. And it's vital, and it's important.
And part of my opinion of it being eclectic is only because a lot of people don't realize it's out there. I'd like to see it more mainstream. Well, I'd actually like to see shortwave right in the cars.
Alan acknowledges that his wife, Angela, is a very valuable part of the WBCQ team.
I just want to take a personal moment because I have to thank my beloved wife, Angela, because constructing this, there were lots of trials and tribulations with everything from the contractors to the suppliers, and she's had a lot of experience in that business and helped us get through all that and, do the negotiations and make the payments and, keep everything, on the up and up and keep everything, everybody happy, because it cost a lot of money to build this, a lot of good, hard-earned money by very devoted people and us all to build this. So I gotta thank my partner here, my beloved wife.
Good job.
Yeah, good job. Yeah.
So,
She's very modest. She won't bring that up, but she really supported me during trying times with crazy people.
World's Last Chance Radio plans to produce more than 100 episodes that will be broadcast.
All right, guys. Well, I hope I didn't bore you too much, but I thought it was very interesting. There was a lot of detail there. What do you think, Brett?
Sounds like quite a few engineering. I mean,
Yeah.
I've seen the WLW AM superstation, but I hadn't seen the workings of a shortwave one. So this is kind of neat.
Yeah.
Yeah, it's definitely cool.
All right, guys. Well, look, hey, we're about at our time limit here, so we're going to probably go ahead and terminate the show here in just a moment here. Trying to see if there's anything else we need to talk about.
Now we can talk about all the Hamfest you're going to do next week.
Yeah, let's do that. July, I think 20th. Nashville Hamfest. We'll be going over there for it. That's a one-day deal. On Saturday, we'll hit it. And then I think somewhere around August 16th, 17th, 18th, somewhere in that area, we go to Huntsville.
Yep.
That's a great Hamfest, Huntsville, and we'll be there for three days. And then we'll drive from there over to North Carolina, to our home in North Carolina, and spend about 8 days there. That's a good stopping point and resting point, because after about 8 days, then we're going to pack up, and then we're going to head another 300 miles further east to Shelby, North Carolina. And we'll be doing a forum there about Pico balloons, and they're real excited about us coming over. About 630 miles total, 650 miles probably. Once we leave there, we'll probably stop halfway back to Memphis for a hotel, because it's, it's somewhere between 600 and 700 miles, and we don't need to be doing that in one day, really. So that's our story. Looking forward to it. I'm going to be doing a lot of HF operating and maybe some UHF, VHF operating while I'm over in North Carolina. Maybe I'll work you guys on HF. Hey, just a quick note. I didn't realize this. My son, AC5CM, told me this. He's been hanging out with a lot of the POTA people. You guys probably know this. I didn't know it. But when they sign off, instead of saying 73, they're saying 72. Now, do you know what that means, Lynn? 72.
Yeah, that's typically a QRP number.
That's right. That's right. That basically is saying, goodbye, see you later, guys, and we're QRP. Let's see, I didn't know that. I've been a ham 60 years. I just learned that yesterday or today. And, I looked it up, and it's very well established. In fact, G3RJV wrote a book called QRP Basics in 1980, and he mentions that in 1980 that it was being used. So, that's,
I didn't know it went that far back, but I'm a
yes.
member of QRP Archie Amateur Radio Club International, and they use 72 all the time.
Yeah, and that's 44 years back.
Yeah,
how
amazing.
how far back does the term 73 go back that we know of?
Oh,
Do
wow.
you know?
No idea.
Goes back to the day of wired telegraphs.
Yeah, well, in 1857, the National Telegraph Review and the Operations Guide listed 73 in there. The exact meaning for 73 at that time was, my love to you. I guess over the period of time it was changed to best regards, but 73 goes back to at least 1857 here.
Mm-hmm.
Wow.
That's kind of the shape of the characters, so maybe that's where it came from.
Yeah. All right. Well, hey, we've been streaming on YouTube and Twitter tonight. We've got 27 viewers right now on Twitter, on X. And guys, this is Amateur Radio Roundtable, and you can join us. We have if you go to W5KUB.com, you can join our chat room and watch the show on our YouTube channel. We have an embedded YouTube channel on W5KUB.com, or of course you can watch it on Twitter, on X. You just won't have the chat room. If you want the chat room, you can still go to W5KUB.com and click on a little yellow button at the top that says chat room, and that will allow you to get in the chat room and join us here. All right. We got Bill in here. Bill's in here. W8ELK. Yep. He holds one of the world's records on low power there. Let's see.
6.2 million miles per watt. That's quite impressive.
Yeah. Well, I bet they had to go around the world a whole bunch of times to go 6.2 million miles.
No, that just means he's running pico watts.
Yeah, I know. Or
I did the same thing.
He could have worked long path, and it may, that was on the 9,000th revolution. It was picked up.
I was trying to work that out in my head, and then I figured out, oh no,
Yeah,
he's using
I don't know, man.
picowatt.
I don't know. All right. Well, let's see. Monroe, Michigan's got a ham fest. Monroe, Michigan Amateur Radio Club's got one coming up Sunday. Very nice. Hey, the Shelby Ham Fest? I've been reading about this Shelby Ham Fest, guys. Back in the 90s, they had attendance of 20,000 people.
Yeah, it was a huge one. I've never been. It was very popular back then.
Now later, they mentioned 5,000 to 7,000 people, so it's definitely dropped. Now, I'm not sure. Maybe right now it's probably going to be a little less than 5,000, but that's still going to be a nice ham fest. And if you really look at it, it looks like it kind of reminds me. It kind of reminds me of Dayton Hara Arena, to tell you the truth. Anyway, so that's coming up. Shelby Ham Fest coming up August the 30th, 31st, September 1st. And we got the Greater Nashville coming up July 20th. Don't miss it there. All right, guys.
Yeah, I'm not going to be able to do Shelby this year, but I will probably next year because I'm going to set up and fly.
Yeah, I think fly would
be
be
drive for me.
Yeah, I think fly would be a good way to go.
Yeah, I'll try to make plans next year to fly.
Yeah, anybody in the chat room are going to go to Huntsville or go to Shelby? Tell me in the chat room right now if you're going to Nashville, Huntsville, or Shelby. I'd like to hook up with you and say hi to you there. So anybody going to Nashville, Huntsville, Shelby?
I'm going to Nashville and Huntsville.
Yeah. Okay. Very good.
Yeah. One of the good things about Huntsville, by the way, is just before it starts, there's a big camp out up on the mountain.
Yeah.
And they have a big POTA gathering and usually have a big cookout, and it's just a lot of fun.
Yeah. Yeah.
Very.
And I understand you may be going. Is that right, Brett?
I'm gonna try. I got business to do in Atlanta, so I may swing over if I can.
Yeah.
Very cool.
Yeah. Okay. All right. Very good, guys. Well, hey, thanks for tuning in with us tonight. Hope everything went well for everybody, and hope you enjoyed the video there. I think it was a very interesting video.
Yeah, that was very nice
WBCQ,
video.
Man. 73, we'll see you.
Good night. See you next week.
And for all you other guys, I'll just say 73s.
Well, let's just throw a 72 in there just for good luck.
Well, but are we QRP right now? I don't know. We're not running much power, actually.
I was going to say, compared to WBCQ, yes, we're QRP.
Yeah, I guess we are. All right, guys. We're going off. We're going off right now. I hadn't put Glenn on here in a while. Where's Glenn at?
Here we go.
On here. Hey, hang on.
We got to get some new video.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
All right. Good night, everybody.